Hello! I'm going to do some more Advent of Code coding today. Again in Haskell because part of my learning Haskell. I haven't really done very much since last week. Partly I guess because I was a bit frustrated in the last week about not getting it working. I did go back and finish off day 9. And I think day 10 was really quick, and then I did day 11 as well. But since then, I really haven't done anything at all. I didn't have much time on the weekend, and I've been super busy in work this week. But I think today I'm just going to pick up day 16, the latest day, and take a look at it and see how it goes. If it looks awful, I'll skip back and maybe look at one of the previous ones. But plan today is pick up day 16, hopefully implement at least part 1 in the next hour, maybe ideally 2 parts, but it really depends on the problem. Okay then, so let's begin. Let's read the problem. More grids. I don't like these. Anyway, as I leave the cave and reach open waters, I receive a transmission from the elves back in the ship. So, okay, multiplying expression binary sequence. Transmit it into hex. Let's convert hex back into the binary. First step of decoding the message is convert each hex representation into binary. Each character is 4 bits, okay. Transmission contains a single packet as outermost layer, which itself contains many other packets. Hex representation of this packet might encode a few extra 0 bits at the end. These are not part of transmission, should be ignored. Okay. Each packet begins with a standard letter. First 3 bits encode the packet version, and 3 bits, this is going to be really annoying, 3 bits encode the packet type ID. These 2 values are numbers. Okay, so 3 bits I'm going to have to decode 2 hex characters and take the first 6 bits out of those 8. These 2 values are numbers. All numbers encoded in any packet represented as binary with the most significant bit first. Okay, cool. Packets with type ID 4 represent a literal value. Literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length. Okay, leading zeros, yep. Broken into groups of 4 bits. Each group is prefixed by 1 bit. Each group, which is a group, sorry, broken into groups of 4 bits. Each group is prefixed by 1, except for the last, which is prefixed by 0. So now we got groups of 5 bits, where we have a 1 at the beginning. Oh, how very annoying. Okay. Okay. So the first 3 bits, packet version. Next 3 bits are the type. And then we straight away jump into the first value. Okay, so we've got 1, which means it's not the last packet. And then some value, and then a 1, and then a value, and then a 0, which means it is the last packet, and then some bits, and then the trailing bits we'd skip. Okay, so the bits inside the message are not lining up with the hex values. Okay. So this packet represents a literal value with binary representation, blah, which is 2021 in decimal. Yep, okay. Every other type of packet represents an operator performs a calculation. Oh, for goodness sake. Keeps going. Split operations are important. Focus on parsing the hierarchy of subpackets. Operator packet contains one or more packets. Sorry, what was an operator packet? So the operator packet is the one we're just getting to. Syndicate which subsequent binary data represent packets. An operator packet can be used one of two modes. For fuck's sake. Indicated by a bit immediately after the packet header. This is called length type ID. So if it's 0, the next 15 bits are a number that represent the total lengths and bits of the sub-packets contained in this packet. Okay, if it's 1, the next 11 bits represent the number of sub-packets. After the length, the sub-packets appear. Okay, so version is 1, the type is 6. 6 doesn't mean it's an operator, does it? It means that non-4 is an operator. A bit labeled, so the next bit is saying whether it's a 15 or a 11-bit length descriptor. And the next 15 bits is the length, which is 27. So the 11 bits in A is the first packet, and there's 16 bits in B. Why the 11, sorry, its length type is type 0. The next 15 bits are the packet length. Okay. And then the sub-packets appear. So the length of sub-packets in bits is 27. Why is A the first sub-packet and B the second sub-packet? Hang on. Oh. Sorry, so if it's a 0, it's the length in bits. If it's a 1, it's the number of sub-packets. This is really annoying. So why are these 11 bits long? I must have missed something. Syndicate. The next 15 bits are a number that contains the length and total length and bits of the sub-packets. Length 1, the next 11 bits are the number of sub-packets. I'm a bit confused as to why, when this is at 27 bits, we get two sub-packets, one of length 11 and one of 16. Unless it's lining up with the original data. But in this one, we have 3 packets, but all of length 11 bits for some reason. Okay, after reading 3 sub-packets, number of bits indicated is reached, so the parsing stops. An operator packet, an operator packet. Decode the structure of hex and encoded bits. I'm not having to the version number in all packets. Okay. Okay. I'm kind of half tempted to use AutoParsec for this, but I'm not going to. I'm going to do it myself. Okay, so let's create a new folder. is 16 today. Module main, exporting main, where main is IO, main is always, or usually always, interact solve. So we're not going to split on lines actually, I don't think. So solve is going to take a string, which is the input, and it's going to produce another string because we're showing it. Solve is undefined. Then let me just pop up here and grab one of the examples. Should we start with it? Let's start with a simple example. Or simple-ish. Okay, so maybe the first thing to do is to convert this into bits. We can just say hex to bits. And we're going to take a string and we're going to return an array of bits. Do we have a bit? Let's create a bit. It's going to be a 0 or a 1. At some point, I should actually work out how to do. It's not types, it's data. I should work out how to do binary stuff in Haskell, but tonight is not the night. We just create it. Okay, so hex to bits is full. Full doesn't matter. Let's left fold, and we're going. Let's right fold. I think doesn't really matter. Take our input and we're going to fold it with jar to bits. Okay, and jar to bits. So we're going to take a single character. And we're going to return some bits. Is that right? Yeah, each character is going to be some bits, isn't it? So, for example, jar to bits of 0 is, that's going to get really annoying. It's quite a lot to type. I wonder if I can do this better. We also have a type problem here because we're going chart bits. I'm going to put in that, but we don't actually want that. We want something like concat map probably. So we'll map each character here into some bits. It'll return a list of bits. We'll do it for every character and then we'll join those lists together. I'm not sure I want to write out all these definitions, but I don't know how to do binary data or hex data in Haskell. Maybe I could just look it up. Seems like a good time to learn, right? So Haskell binary data. Dealing with binary data. I've obviously been here before. Data.byte string. Is for data.hex string as well. No. Hex. Package called hex. Seems like cheating. Is it in base? Don't think it's in base. Okay. This isn't really what I want, don't think. So, go to value is the put monads and then get monad. And then generic versions of those. So to show us custom time, this looks remarkably complicated. I might just go back to what I was doing. Just seemed like a lot of work. I might just carry on. It's going to be long-winded, but at least I know what I'm doing. I can make progress, right? 1, 0. God, this is horrible. Okay, so after 1, we will do 2, which is 0, 1, 0, 0. And then 3. Oh, I can't count. I'm totally out by 1 already. This does not seem like a good approach. Maybe we could do something a bit more programmatic with this. So can we do like a hex to int, which goes from a character to an int? So hex to int. Hex to int where x is in to a dot dot z. No, let's do 0 to 9 first of all. What's that? I hope I can generate that, but if not, we can do it from the ASCII code. So from 0 to 9 is just, it's something like digit to int. Yeah, it's a thing. Actually, what else is in data.char? GCI import data.char. We got any kind of hex to int. Digit int is a thing, but hex int doesn't seem to be. I do not want to see them all. Okay, let's try. Okay, so Vex is a member of that. Vex is an element of A to F. Yeah, second. So ord is that thing. So ord of A. No. Char of A. No. Oh, hang on. A is not a thing. What am I doing? 65. Okay. So I want to get this down to 16. Is that right? No, sorry, to 10. So I just subtract 55 from it. So if I say something like ord F minus 55, we should get 15. Cool. So that's ord of X minus 55. Not on scope ord, because that doesn't data chart at all. Unsafe? No. Otherwise undefined. Okay, so we can go from a hex thing to an integer, and then can we go from an integer to bits? So character bits will go from a character to a list of bits. Let's do int to bit first. Okay, so it seems ridiculous because the underlying representation of all these things is just bits. I'm doing all this work to write my own bit class. So what do we want to do? We're going to say int to bits of 0 is 0. Int to bits of x, assuming x is greater than 0. What do we want to do? We want to what do we want to do? We want to shift it, don't we? But if I'm shifting it because it's bits. There must be a way of going to some kind of word type. I would use a byte string. Is hex digit? I mean, that would be useful, wouldn't it? What's in? Have I looked? I'm sure I've looked into that byte string already. Data byte string. Worded library to be used with data byte string, but it's not going to tell me what data byte string is. Maybe the package is just called byte string. byte string type, or string for binary or 8-bit character data, sequence of bytes. But how do you use it? Could do with a simple example. Creating builder's byte string. Function to builder. No. That's an encoding. What about a decoding? Character encoding. So it goes character to ASCII encoding is semi-encoded. Formatting numbers as text. Coding for images text numbers using local ASCII characters. That's what we need uppercase characters. Okay. Is this like, can I just write that in Haskell? Ooh. Okay, so that might make life a bit easier. I just grab this string. Oh, I can't because I'm not Linux. E2 FE28. Okay. So then, if I take hold up a second. I mean, if my input is equal to this string, oops, this string, and then if I prepend it with 0x, okay, and then I say read a prime as an int. Oops, sorry, as an int. Okay, so we can get to the int value. So then how do we get from the integer to the list of bits? Haskell int to list of bits. Here's your built-in thing. Now people are just doing it by shifting. Let's look some built-in. Okay, seemingly not. So that's getting to the end isn't necessarily helpful. And in fact, this is something I'm already doing here. I don't want to write a long mapping. So into bits. There's one of these to list of bits. And into bits of 0. Like I've been here before. Single 0. Into bits of 1. Is that what I want? I get a feeling I want to take the last bit trying to think what the bits would look like. So let's look at just F, for example. No, let's look at E. For example. Okay. And what I want to do, I think, is if you... I don't know, it's bit shift stuff either. So what are they doing? They are what's S said? I'm feeling it by this the width here, okay. So dividing it by 2 to the n each time. And m is 2 to the n, so n just keeps increasing each time. Oh, decreasing each time, sorry. God, this is really annoying. I should have stuck my original things to write them out. Maybe just write them out. Try to list of bits. Bits of 0 is a single 0. Does that matter? No, they're padded. So it's 4 zeros. And 1 is a, oops, a 1 there. And then 2. And 3. So do 4 and 5. 4 is there. And 6 and 7. Can't be a better way of doing this. quotes, then 8. Yeah, 0. The thing that looks like a 0 is a 1. That's what all the cool kids are doing. Maybe I'll rename it in a minute. Actually, if I call it I, it'll look a bit like a 1, wouldn't it? And 9 is like 8, but with a 1 at the end. Okay, let's rename that. What am I looking for? I called it O. Change that into an I. Okay, A is 10. B is 11. Which is that. C and D. So C is 12, which is that, and 13, 14, 15. Almost there. This is horrible. Okay. And then chart of bits is undefined. Do not like. Okay, so if we then just say, for example, next bits. Deriving show. I'll just oops. Do that. Okay. So if we run Haskell main and we dump in this. Getting undefined. That's because of a new line, isn't it? So let's say echo minus n, that thing. Echo. Yeah, I think that's right. And then pipe through run Haskell of main. Okay. So it gives us this answer. And we are looking for this stuff because we're not going to use it in the end. 110100, 110100, 10, lots of ones, some zeros, whatever. Okay, so we'll try decoding that. So we want to take 3 for the version. I never did that. Okay. So the version do we just want to make some non-mode? No. So parsing the version, we're going to take list of bits and we're going to return a pair which is the version, which is an int. Let's call it version. And it's going to take the remaining bits. version is an int. Okay. So parse version equals to int of take 3 from our input, so our bits. It's a tuple going back, so it's going to do that, and the remaining bits. So that'll just be drop 3 bits. Okay, and then to int, it's going to take a list of bits, return an int. So to int of the empty thing is 0, and to int of, oh, I've got to remember where I am. If we get a bit and some bits, it's let me fix this a little bit. So to int is to int prime 0, and then the bits, we don't need that, we can reduce it, I think, where to int prime of the number and what I'm thinking, sorry, is I'm going to take the first bit and it's going to be a 0 or 1, and I'm just going to turn it into a 0 or 1, and then I'm going to shift everything, or in fact it's going to be 0, 1 times 2 to the position in the string. Right, but I can't start from 0 because that's I can't start from 0. I'm going to fold left, so we can fold right on this. Might be able to, oh, when we run out of string, we're going to do nothing. I've written this recently and I can't remember how I did it. To int of x and then b, and b's is I'm going to look this up. This is the last time I implemented my own binary class. Oh, I reversed it. That's how I did it. Okay. Why not, eh? So I was close to getting it right. So it's going to be, this one's list of bits, because I don't have a separate type for that, and I call them Z and I. And it's 2 to the power of wherever they are in the string. Does that work? Let's find out. Parse version, that, and then this should give us back, it's giving us back 6, and in the example, it was 6. Oh my god. that amazing? Okay, now we need to type. And we got the two types we have are data and operator. So we got data of packet type, which is p data or p operator. And then we can say parse version, and we get a list of bits, and we go to, no, sorry, parsing the version, parsing the type, which is going to go to packet type, and the remaining bits. So parse type of our bits. So we want to go just derive show as well. Okay, so we want to take the int and then match it against. Basically, if it's forward, then it's going to be p data. It's going to be p opper. So it'll be packet type and then drop 3 from the remaining bits, where p type of we got, so this is the, well, I'm out of names for things. So something something, let's call it x for a second, is just to int take 3 bits, and then p type where x is 4, is p data, and then otherwise is the operator. Oops. Okay. So we need to parse these in the right order, so we can say something like so we can say version and rest is our version of the bits. So we'll just name this now. This is our input. And then we can just return a string. So we can say version is version, and type is type. P type doesn't clash. So bits is hex to bits of s. Version and rest is that, and then p type, and we don't care about the rest of this, is parse type of the rest. Show that and show that. Okay. Is this going to work? Cool. P data. So the next one they had was a bit more complicated. So it's now this. Oh, this should be coming back as version 1 and an operator type. Oops. Echo. That's n that. Run Haskell main. Version 1 P operator. Okay, cool. So we can parse our first 6 bits. Okay. So now we can write a parser for the literal. Although, what do we need to do here? It's the all the version numbers. So we go through the entire hierarchy. So we don't really need to parse the data yet. But we do want to parse the operator. So we need to care about the next bit, which is the type. Okay. So we can say parse operator. So we're going to do here. We're going to go from P. No, we're going to go from list of bits to what are we going to get out of this week? I mean, maybe get subpackets. Yeah, I think it's the subpackets. And it's got 2 subpackets. Okay, so we're going to return. Each subpacket is just a list of bits. Okay. So we're going to return a list of packets. So now we can say the type of packet is, it's just a list of bits. I don't know, I'm pluralizing things here. So it's a list of packets and their remaining bits, the things that weren't part of this operator. So operator, the next bit we're going to get is the 0 or 1. So 0, and then the rest of the bits is parse operator 15, I think this one was. So if it's a 0, then we parse a number, which is the number of bits in the subpacket. 15-bit number. Okay. So parse number 15 with the remaining bits. Parse operator. If you give a 1 and then some remaining bits, we'll say parse operator 11 and remaining bits. Parse operator 15. Again, we go from some bits to a list of inner packets and a list of bits. Okay, so we know how long next bits are. We know how long the length of the next thing is, right? So we can So I'm going to do this. So we can say that the length is, oh, I need a where, sorry. The length is int take 15 from our input, and the packets are contained within taking the length from whatever's left of these packets. Have I got split at? Is that a thing? So if I say 1.10, can I say split at? 4, and then 10 will just give me 1, 2, 4, 5, and then 6, 7, 8, 9, 10. What am I doing? No, it's not zero indexing it, but if I was zero indexing it, oh, so we're right. Okay, so it's if we had like 30 of these and I split it 15, yeah, it gives me the first 15 bits here and then the rest there. So split out is probably quite useful. So we'll have something like len and packets, or packet data. I should just call this rest for a second. This is the rest of the string, and it's oh, oh, this is really annoying. Gonna be loads of these. So I just need names for everything. I need a name for the first 15 bits. Let's write that literally. So something like first 15, and then rest is split 15 Bs. The length of our packets, so our packet length is to int of the first 15. Okay, so now we can take the length, so p length from the rest, but not really. So our p data and the other rest, like the total remainder, is gonna be taking plen, not really, split at plen rest. Okay, so now we got our packet data and our and everything else. So we know that the 15 characters, the next 15, sorry, we know that whatever length contained in here controls how many bits we pull back. So what do we do with that data when we pulled it back? So the bits is the length of subpackets. Okay, so 11 bits labeled A. Is this because we have version 6? No, because this is not value 4. It is value 4. Ah, okay, so it's a data packet. Right. So then we can just parse that, I guess. So we need to be able to parse all the way from a data packet. We need to parse all the way to the end of that data packet. Right, because then we get the chunks where you get starts with a 0 and then has 4 bits, starts with a 0, then has 4 bits, starts with 0. Okay, this is not holding up. Starts with 0. Hang on, I'm really confused now. So if this was an inner packet, I think there's 6 plus 5, or 6 plus 5 plus 5, or 6 plus 5 plus 5 plus 5. What is 6 plus 5? I'm a bit confused by that. What I don't understand is why the data packets are 6 plus 5. But why are they that? So you got 6, which is the header, right? So the first 6 bits is going to give you the version, and then the version, then the type. So in this case, the version is 6 and the type is 4, which is a data packet. Oh, it's a data packet. Does that say 0 is the last packet? Oh, 0 is the last group. Okay, that's where this ends. So it's 6 for the header. Right. Then a packet begins with 0, which means it's the last packet, so you read 5 bits off. Okay. Then the next one also, okay, this is version 2, but it's still type 4, so it's a data packet. Gotcha. Then it starts with a 1, and then 4 bits, so it's not the last one. Then it starts with 0 and 4 bits, so it is the last one. Okay, so we'll go back and work out how to parse the data packet properly then. And then we can come back to the operator. Right, so it's got to, we need some way of parsing this p data, and then we return the rest. So it'll be something like parse packets of p data, and then the rest. Right, okay, so we need to define parse operator 11. It goes from list of bits to list of packet and bit. I'm just going to leave it undefined for now. Okay. So parse operator, the thing that's not matching is the empty list. That doesn't really make any sense. Okay. Right. Parse packets. So what's this going to take? It's going to take a list of bits. And it's going to return a list of packets and the remaining bits. Or is it going to return nothing? Is it always going to consume everything? No, it might return remaining bits, which we can just clean up. Actually, do you know what? I'm just going to, before I get into that, is set to undefined. I'll come back to it later. Because I want to parse the data packet. So this is a list of bits. And it's going to return us an integer and the remaining bits. So anything that's not part of that data packet. Okay, so parse data packet of an empty thing is undefined. Yeah, if you call it with no input, we could probably make that work, but I don't think it should happen. So parse data packet, where we start with a 0 and the remaining bits. So this is a non-terminal thing. Oh, we're going to need a counter as well. Cool. Don't do that. If it's sort of 0, then we want to say to int of take4 from the remaining things. So actually give us an integer. And then we add it onto the rest of things. So it gets a little bit messy, but we can say let the value of this packet and the rest be split at 4 B's. And then we want to keep going, right? So we want to say I don't have to call things. We're just going to keep parsing these data packets. So we're going to get the int back from this. So but we just call it with the rest. And then the integer value is to int of b, but maybe we don't need that. You say in, then what we're going to turn is to int of v, which is this current value, plus v1, v prime, which is the value that's returned by parsing everything else. So we just keep summing them up. And we're going to return it, we're going to add to it with whatever was not processed. That. Okay, and now we can say parse data packet of I and B, so this is the terminal one, other way around. Yes, set is terminal case. Thank you. Try it again. So for the I doing? That's what I tried to do. I is a non-terminal case. Okay, so for the non-terminal case, we pull out the 4 bits, turn them into an integer, and then we add them on to whatever comes back from parsing the rest of the packet. That's not really how numbers work though, is it? So it's first 4 bits is this, next 4 bits is that, last 4 bits is that. No, okay, we need to keep the bits. We don't intify them. We just keep adding together. Okay, so if it starts with a 1, then we read the next 4 bits. And then we want to end up with a bigger list of bits, and then we twint that thing. Okay, so this isn't quite right. Let's do this as a list of bits for now. So we're going to say these are list of bits which are in this packet, and these are list of bits which are not. Okay, so if it's the terminal case, then all we do is we say the data and the rest is split out forwards b's, and then we return, well, that's it actually. That will return the first 4 bits, and then everything else will be the unparsed bit. Okay, in this case, we will the data and the rest of the stuff, and then we will take whatever's left over and we'll keep parsing it because we haven't finished yet. And then we should be able to say d plus plus d prime and the rest of the stuff. Okay, so we have that, and then we can turn it into an int if we wanted to. So let's see if this works. So in here, we'll say value is show of to int of the value where and then we can say is d value, and we don't care about the rest yet, is parsed data packet. And what's it going to take? It's going to take this stuff. I cannot do this, but I can do this. Okay. So in theory, if I take my first string, which was a data packet, and put it in there, value is 2021, which is the correct value. Okay, so we can parse a data packet, and we can parse an operator 15 packet, but we can't yet parse an operator 11. Well, we can't actually parse an operator 15 because we don't parse its contents. So to parse a general packet, that's going to take a list of bits, and it's going to return this is tricky because it's either going to be a list of bits, which is the data packet, That's what the data packet can resolve just to be the binary representation of some number, or it's going to return an operator which is going to be an outer packet and then a bunch of inner packets. So actually, I think this gets more complicated, which is going to fuck me up a bit, but whoops. Data packet is either data packet of that or op packet, which is a list of packets. So when you parse the operator, we get these things back. Okay, so parse packet is going to return a packet. Do we want some extra fields? We kind of do. We might as well grab them as we go. So it's either going to be this with a version, a D type. No, P type was it? Packet type, I called it. Packet type and list of bits, or it's an operator packet with a version packet type NAT. There's not really any point in tracking packet type for a data packet, I don't think. But there is for an operator packet, because it could be either the 11 form or the 15 form. Right. So parse packet. What have we got here? So we got our bits. And we can say let version and remaining bits is parse version. Oops. And the packet type and the remaining bits is parse version. No, not parse version, parse. Is it P type? What do they call this? Parse type. Okay. Of these things in case packet type of, okay, his packet type is P data. Then we want to parse the data packet of whatever's left. And then the other case is P operator, which is parse operator. Okay, so this now needs to return a packet and list of remaining bits. So parse data packet. We're not going to return a list of bits now, we're going to return a packet. Okay. So what we'll do here is create an inner function which does the stuff we did before. Okay, it's going to go, that's exactly what it's going to do. And it's going to recurse on itself, not on another function. Oops. Okay. So parse data packet. So maybe we don't need this. We can get the bits out from calling this inner function. So let's data and rest equal parse data packet prime of the bits. Better store this in. Then we're going to say d packet. We've lost version, so we need to recover the version somehow. What I might do is wonder if I could change these to what do I want to do? If I could change these, either pass the version in, or I could change them so that we don't trim the version out. I'm going to pass the version in, I think. So dpacket version, and the data. That's the first part, and the second part, whatever's left. Let's not put data because that's a keyword. Okay. So we have the version down here, so we can just pass in B, and we'll pass into here as well. In fact, we'll pass in packet type as well because I wanted to return that. Okay, so parse operator v, no, version p type, packet type. So this is, we'll get back to this in a second. Okay. So I just want to parse a single packet. Oops. Do we derive show on our packet? No, we do not. Deriving show. Okay. We can't go to int deval, so we will actually deconstruct this properly, so we can say write something like show packet goes from a packet to a string, because we should have slightly different. So show packet of p data version and this has got some data is prediction arguments. Is it packet data? What do they call these things? D packet, obviously. Okay, so this will say data version equals v v. Yeah, because that comes back as an int, doesn't it? But I'll need to show it then. And value equals, and then here we say show to int d, and show packet. Did I call it packet or opera packet or operator packet? Well, I'm really bad with my naming. Op packet, obviously. It's got a version, it's got a type, and it's got packets. And that's operator. Version equals something. Should be. I'll just leave it at that for now. Okay, and then we should be able to say show packet. Packet of parse packet. I can say of P actually, and then we can say packet, and any remainder it should be parse packet of bits. Okay, I think we're going to have a special case as well where we just have some trailing zeros, but let's not worry about that. Okay, so we parsed our data packet properly, pull out the version, input the value. So now I can go back to my operators. God, that was difficult. So where we get to. So when we have this 15 thing, right, we know that this stuff has got the data inside it. So we should be able to call parse packet on that. And what's that going to give us back? It should give us back a single packet, which is either going to be an operator with some sub stuff or a data thing. That will only extract the first thing. Okay, so what we really want the operator to do is give us back a list of packets. Is that right? So back to the example. We got 2 sub packets, so we need a list of sub packets. Okay. Okay, so we just keep going until we hit the end. So parse packets goes from a list of bits to just a list of packets. Okay, we need to be careful about the end here. So we can say parse packets of some bits where find is nothing, a find of equals z. No. That's annoying. So we're actually going to go from a list of packets found so far. So we're going to accumulate them. We're just going to return them at that point. Equivalent is nothing. I need to make this equalable, I think. We're back, so we're deriving show and eq. Okay. This is the problem here. Not exhaustive, I know about that. Otherwise, it's undefined for a second. Variable not scope find. Did list find? Okay, that's what the problem was. Okay, so if everything is a 0, then we got to the end, I think. So these are just trailing zeros. Otherwise, what we want to do is parse packet. So we're going to let p, rest equals parse packet of bits in p cons parse packets rest. Then we don't need to track this because we're left folding, which is I don't care if it's sufficient or not. Okay, so this makes sense. So if you call parse packets and you just give it zeros, it'll assume they're trailing zeros. So we compare everything to, we say we can find an I, like a non-zero, in our input list, and if we cannot find any i's, then we must only be z's, which means that we run out of input, parsable input, so we return nothing. There are no packets in there. Otherwise, we parse a single packet from our input, and then we join that with whatever we discovered in the rest, which could be nothing. Okay. Could I do it up here and just make this a fold? I could do, but let's, like, what's the point? Okay. So now that we can parse many packets, I'm just going to check this works actually. So it should be something like show packet. Just fmap that over parse packets of S. No, parse packets of next bits of S. Not quite. So parse packets takes a list of bits and gives back a list of packets. Oh, let me write this slightly differently. F map show packet of this, of this. Totally not happy. Okay, so hexabits will give me back a list of bits. Parse packets will take that list of bits and turn it into a list of packets. And show packet will return a list of strings. And then we can just say something on lines on that. Okay, I'll just see if that works with our simple input. It still works, which is good. Okay, so the next thing is in the operators. So these are now going to start returning lists of packets. Oh no, hang on, they already returned a list of packets. Okay, so the packet is the operator and it contains a list of packets. Right, okay. So we can say something like sub packets and rest prime prime. Again, the naming is horrible here, but we now have our data which contains the potential sub packets, so we can say parse packets, and that takes this. No, sorry, parse packets p data. That's okay, it doesn't return tuple, it returns packets. Okay. And then here we can say we're going to be an op packet. I think actually from here we can return list of packets, because what we're actually going to return from here is just sub packets and then anything remaining. So here we can say sub packets. And up here we can say this is going to be an op packet containing the version and the type. And then this. Not quite, because that gives us back the remaining stuff. So we can say sub packets and rest of things as a tuple. Where sub packets and rest is that. Okay. Now what we want to do is say parse some packets. This is for the operator 11, so what I'm going to do is just work out how many there are and then call parse packet that many times. So parse packet is going to take the number of packets to parse and some bits, which is our input, and it's going to return a list of packets and the stuff that was not parsed from the input string. I might just call it parse n packets. So this is the number, so parse 0 packets. So this is, we don't care what the input is. Yes, we do, because we have to go back. That's simply going to be nothing and B's and parse any packets of any other number, and our input is so we're going to say something like let p p and rest be parse packet of b's in, so we say so it's a single packet, and then we're going, because we got the rest, what we can then say is all the remaining packets and rest prime is parse n packets from the x minus 1, and we're going to feed it the rest. These are really inefficient folds, but I don't think it matters for the size of input we have. And then we can say p attached to p's and anything that was not parsed by our recursive call. Okay. So how does this work? This is going to be the same thing, right? There's going to be subpackets and rest. Not quite sure rest is going to work yet. Where I just grabbed this because there's going to be some variation in this. So like first 11 is split at 11. And the length, the number of packets somebody just calls count is turned into an integer, and then we can say that subpackets and the rest is parse n packets of count. I'm just going to inline this. I'm going to say to int first 11 and the rest. Okay, we've got two things called rest, which is not going to be great. Okay, couldn't match this because this is going to return a list of subpackets. Okay, so now we do the same thing here, where subpackets and the rest is equal to that. So this is equal to op packet bt subpackets and the rest of the things, and being taken from here. Okay, I mean no type errors, so we should be good, right? So if I take my longer thing and drop it in there, I mean it's okay. Do we know it's an operator? It's parse it, but not printing out the operator. So when I did that, and we can say subpackets plus. Okay, and then we're going to take show packet and just apply it to all the P's. Oh, and unline it. What's the problem here? P should be a list of packets. Oh, it's a single plus. Okay. It's going to be a bit hard to read, I think, but we could probably do a new line, couldn't we? So operators 1, 2 subpackets. First one is version 6, value 10. Second one is version 2, value 20. Number 10, 20. Okay. And then this one should be 3 packets. I think 1, 2, and 3. I'm just going to fix the new line thing here. So we can say echo minus n that main.hs 1, 2, and 3. Oh my god. Okay, cool. So they should have a more complicated example. Echo minus n so an operator contains a subpacket, which is an operator contains a subpacket, which is an operator contains a subpacket, which is a data value 15. And literal value. Okay, so now I want to start summing the versions. Okay, so so this is going to go I mean this is oops right, so like get version, take the packet and goes to the string, goes to int, so get version of d packet v in some data we don't care about is v, and op packet v and 2 things we don't care about is v. So now we can say unlines, we're not going to fmap show packet, but we're going to say sum of map of get version. What's this problem now? Get version, blah, blah, blah. No, couldn't match type of int with list of strings. Oh, we're trying to unlines it. That's why. Go with that. Okay, so this gives us back 4. Yeah, it didn't really work, did it? Let's not sum it. So we should have a list of packets. we should map that into a list of versions. It's only doing one of them. It's a little bit weird. It's very weird. I'm really confused by this. Why do you only get one of these when we're F mapping? Parse packets gives us back a list of packets which should just be mappable. That's really weird. This is a bit I thought should be easy. A not packet version 4, it's an operator. I might just drop this out actually. Not packet, which is version 1, and not packet version 5. Oh, they're nested. That's what it is. Sorry. So is this always going to be a single packet we get in? TK access with bits transmission. It looks like it. So even though we can do successive sequences of packets, we don't have any of them, I don't think. Okay, so we're not going to fmap this at all. We're just going to call get version, and it's not going to be get version, it's going to be called some version. Some versions. And it's going to take a list of this is annoying. I'm going to fmap it. Okay, so it's going to be this plus there's some versions of each of its packets, but it doesn't do that, so it's actually going to be plus fmap. Okay, so the sum of these things. Let's try that. 16, that's the correct answer. Okay. This one should give us back 12. I'm going to stop in a minute. Okay. This one should give us back 31. 31. Okay, cool. So let's get the puzzle input. Oh, it's very long. Echo minus n, that, whoa. Haskell main. So 1038. I slightly misunderstood it because I thought you could have more than one packet. I'll quickly look at part 2, see it's going to be really quick to do. Calculate the value expression that represents literal values, a single number. Many packet types are. The value is the sum of everything. Packets type 1's a product, minimum, maximum, greater than, less than, equal to. You can now work out the value of the outermost packet. Okay. So we have a whole bunch more types. It's a sum 1 and 2. Okay, so 0 is sum, 1 is product, min, max, and so on. How are we doing? Going on a little bit, but I'm a bit tempted to finish it because I've started. Okay. So it's not this, it's op type. So data op type is sum or product or min or max or min max GT. First is greater than second. They also exactly 2. LT, they also exactly 2. And equal GT or LT or EQ. These might clash a little bit, so I'm going to just say, oops, I'm fixing all with op so that we don't clash with other definitions of GT and EQ. I think I got away with it because I uppercased them. We shall see. One gold star so far. Okay. So let me just fix all the type errors and then we do some kind of evaluate of these things. Why is it not showing me the type error? Because this should be broken, right? You can't just say P operator without giving it a type. Case X of. What's it got? So 1, 2, 3, or 0, 1, 2, 3. So 0 was op sum, so it's P operator. Of op sum. Derive show here before I forget. Okay. 1 is P operator of op product. 2 is P operator of op min. 3 is P operator of op max. 4 is P data. 5 is P operator. Why am I calling this P operator? Oh, because I think it's because it makes the parsing easier. I don't need to rewrite the parser. It can just keep working off P operator. And I can ignore the type when I'm parsing it, and then I can just evaluate it properly. So P operator of op. Where do we get to? GT. 6 is P operator of op. LT. Right around. GTLT, yep. And 7 operator of op EQ. Type up here, so because is equal to that. Okay. Still got an error. Okay, so parse packet, so P operator that. Next error. Thank you. exhaustive, so I could just assume that it's going to work. Okay, so we can now parse the types. So now we could maybe just write an eval. And right quick, I can write an eval. So it's going to go from packet to an integer. So eval of p data. Don't care about the version anymore. Version is quite annoying. And this has got some d equals to int of b. Okay, there's no arguments. Oh, it's d packet. Okay, that seems to work. Eval op packet of, I forget what these things are. So sum. And then we got a version we don't care about. Type we don't need. It's annoying, but I'm not going to go back and fix it. And the other packets is equal to sum of fmap eval ease. Alt packet should have 3 arguments. Into this. No. Oh, it's not alt packet. Is it alt packet? Alt packet. Right, okay, I put it in the second argument. Okay, so this is this is where do I put these? P operator. Op sum. Okay. So product. We can just replace this with product. Minimum. What they were. Min max. Maximum. EQ. And less than, and so on. So how does this work? Greater than the first one. Okay, it's 1 in the first 2 packets. If the first is greater than the second, otherwise the value is 0. Okay, so this is slightly more complicated. We can say let first value, second value, oops, destructured properly as a list, and then whatever else, blah. Actually, let's say something like v1 v2 is take 2 from fmap eval p's in if v1 greater than v2 then 1 else 0. Is that right? So if first value is greater than the second value is 1, otherwise it's 0. Couldn't actually quite type that because it's right colon. Less than just split these around. So one's less than that. And then equal and eval that equals undefined. Okay, so we have a few problems here. Let's fix this one first. What am I not matching? I'm not matching pdata with nothing. Okay, just some. Oops. That's really annoying. This seems to be undoing more than my last command each time. So I'm just going to skip over things that shouldn't come up. Okay, so here we should be able to just say, but I'm going to try it out, say eval head of that. Okay, give me an example. Main 3, good start. Oh, 54, good. 7, good. 9, oops. 1, so she gets 0. 0 could have an inequality. Okay, and then the last test case should be 1. Good, okay. So what happens if we evaluate our long thing? Let's see if we can get our second gold star. Cool, okay. So once we had worked out how to parse packets, writing the evaluator is really easy, which is not a surprise for Haskell because it's like people write a lot of programming languages in it and interpreters and so on. Okay, cool. So that's quite good. I managed to solve both parts, although my 1 hour turned into 2 hours and 10 minutes. But yeah, that was a lot of, well, it was some fun. It was a bit annoying to start, but when we got going, I quite liked it. So cool. Hopefully see you next week, and we can do day 23, I suppose it'll be by then, or some other problem if I find a better one along the way. But yeah, thanks for watching. And yeah, maybe see you next week. Goodbye.